Hello, this is STEM with Sid, and today I'll be talking about basic differentiation rules and rate of change. So the first rule I want to talk about is the constant rule. Then I'll go over the power rule, and then I'll go over the basic trig one, the two trig, and then I'll talk about like the rate of change. So basically, constant rule. Any constant derivative of it, let's say f of x equals 4. So the function is literally, y equals 4. It's just like a straight line. Now, what is the tangent line to that? That is that line. So what is the slope of that tangent line? 0. So it follows that the derivative equals 0. That's for any constant. So literally f prime of c equals 0. So derivative of 2 is 0. Derivative of 6 is 0. Power rule. Power rule basically is, let's say you have a variable to some power, let's say 5. You pull the power down and then you subtract by 1. So for this, if f of x was x equals 5, or no, not x to the 5, not x to the 5th. Let's do 2x cubed. The derivative would be 6x squared. And you could say the general rule is if you have f of x equals x to the n, sorry, let me fix that, x to the n, then you can say f prime of x equals x to the n, or sorry, nx to the n minus 1. So you move the exponent and subtract 1. Trig, you need to know for 2 for now, but later on when I explain more of the derivative rules and all that, I can teach the rest of them. But for now, you should just know that the derivative of sine is cosine x, and the derivative of cosine is negative sine. Okay, those you need to know for now. And this makes sense because if you look at the graphs, they're kind of like, if you look at the cosine graph, it does like start off as kind of like the slope. Like it doesn't start off the same way, right? It starts off at, it's basically the graph of the cosine x is like graphing the slope of the sine x graph. And the graph of negative sine x models the slope of the tangent lines for cosine x. Now, rate of change. This is basically, that's what a derivative is, basically. Rate of change, slope, right? That's what it is. A change in y over a small change in x, an instantaneous slope / rate of change. Doesn't have to be instantaneous, but that's when you deal with calculus, taking derivatives, right? So, example for rate of change, like practically, would be if you have a certain distance, right? If your car moves a certain distance, or let's say displacement, because I want to get into velocity. So displacement, and then the derivative of displacement, let's say you want to figure out, like, you not only you went 4 meters, but how fast you're going at a certain instant. Well, the derivative of displacement is velocity. And then, let's say how fast you want to know your velocity is changing. Your acceleration when you start from rest to whatever speed. That would be the derivative of velocity would be acceleration. Later on, I'll teach integrals, which is like backwards differentiation. So you go from acceleration to velocity, displacement. But for now, you just need to know displacement, derivative of that is velocity, derivative of velocity is acceleration. And you can get graphs like displacement time graphs, velocity time graphs, acceleration time graphs. And you would need to know, oh, taking the slope at a certain displacement graph would give you the velocity, because velocity is the derivative of displacement. Or if you need to find the acceleration and you have a velocity graph, you need to take the derivative of the velocity graph to get the acceleration graph, and then you can find the acceleration at a certain time. So that's basically the fundamentals you need to know for differentiation, topic 2.2. Thank you for watching.